Okay, this is a tutorial to animate sketches through Assembly4 in FreeCAD. As you can see here, we have two sketches, and if we click Animate Assembly right up here, we can control that wing flap right there, and say if we want. So, if we say, we want it to stop right there, current value 7, range end 7, and now we have the range of motion we want. Okay, so let's close all of this. Close all. Okay, so first thing we want to do is start with two new files. First one, so open up your Assembly4 workbench. In the first file, you want to open up a new Assembly4 model. So click the Assembly4 model button. And then switch to the second file. Create two new bodies. So one of these is going to be the wing. Second body is going to be the flap. You can also create, if you wanted to, you can create a separate file for the wing and the flap, but I'm just gonna put it in one file. So we have our model, and then we have two bodies. So first you want to save your assembly, or you want to save your first file. Let's create a new folder because we don't want to override. So we're going to say tut. Okay, so call this assembly. Okay, so we have the assembly right here, and each of these bodies is going to be a different sketch. So can save as sketches. Save. Okay. Now we want to close all. Close FreeCAD. Open FreeCAD back up again. This is to just make sure that everything has saved properly. FreeCAD can be kind of finicky if But yeah, FreeCAD can be sort of finicky if your files aren't saved. It'll give you weird errors. So just try and save your FreeCAD files as frequently as you can. Okay. So first thing, we want to open up our wing, open up the sketches assembly. Oops. We want to make sure we're on XZ. So sketches, macros, and we're using the airfoil to generate our sketches. Execute. So 4-digit, that's fine. Airfoil number, let's do 2412. Open. So you need to make sure to select Sketcher Workbench, because this will export. That'll export your your airfoil as a sketch, not a draft, which is, I don't know what that is, but and you want to do B-spline. I just find that B-spline, the curves are a little bit smoother. Polyline can be kind of chunky. Yeah, so whatever you want here. I'm just going to do 25 millimeters for chord length. Create airfoil. Yeah, as you can see up here, FreeCAD is kicking out some errors. I think that's just because the airfoil macro is sort of outdated, but it still works. Okay. So this is our wing foil. So we want to take that and drag that into the wing body. So you can see that's in the wing body. And now we're going to do the same thing for the flap. So we're opening up our foil, 4-digit. We can just do the same. 2, 4, 2. That works. Obviously, you want your flap to be a little bit smaller. So let's say 15 millimeters. Create. Yeah, same error over there. That's fine. Okay, so now you can see we have a wing. Oh yeah, it's actually kind of big. Let's do let's do another one, but a little bit smaller. Foil, execute, 4-digit, 412, sketcher, B-spline, spline, create airfoil. That's a little bit more reasonable. So let's go ahead and delete that. Now we want to drag that second sketch into our flap body. Perfect. Okay. Almost done. Yeah, so now you're going to want to go back into the Assembly4 workbench, and on the wing body, we're going to go create new coordinate system. So this is going to be the flap pivot. Yeah. So this is kind of the trickiest part. It can be really confusing figuring out which. Yeah, it can be confusing. Okay, so yep. So we want to constrain. Oh wait, hold on. Let me explain what I'm doing. Okay, so we've just made this. We've just made a new datum point, or not a datum point. What's it called? A coordinate system. So we've just made a new coordinate system. So pretty much, what this is useful for is we can put it somewhere, and then we can reference it directly when working with other sketches or other parts. So it's just a very convenient tool, and it's the only way to use the Assembly4 workbench. So pretty much this is just a separate coordinate system, in the same three-dimensional space. But we have to tell Assembly4 exactly where we want it. So we do that by referencing the coordinate system that's already there, right? And then we want to move it. We want it back here somewhere, right? So X. Oops. Now just yeah, so that should be about right. Okay, Z. Okay, let's do 1.5. 1. 1.6. Yeah, sure, 1.6, that's good enough. Perfect, okay. So we've got, and that new coordinate system is part of the wing body. And this flap, the only coordinate system we have is just the default XY, which is what we want. Okay, yeah. So now you're going to want to go, well, first of all, save all. Okay, that should be fine. Next, you want to go back into your, yeah, I can see. You want to go back into your assembly document. So this is where kind of all the parts are going to come together. And this button right here will link other parts. Yeah, so first thing we want to do is bring in the wing. And what this is asking us is where do we want the body, the wing body brought into the assembly. So, you know, selected part, this is the wing, right? And we're attaching it to somewhere in the parent assembly, right? So the parent assembly, you know, we didn't make any other coordinate systems, so we're just referencing the LCS origin. That's the the default coordinate, and we want LCS origin matched up with LCS 0. So yeah, this is all good. Click OK. Okay, great. Now we have the wing sketch brought into our model. Now we need to bring the flap sketch in. So we want to go grab flap. Same thing, insert. Well, we want to reference the LCS. And then for attach to, we're not attaching it to the parent assembly. We're attaching it to the wing sketch. And then we select flap pivot, which is the coordinate system that we made earlier. So press OK. Okay, great. So now we've got all of our sketches linked together, and now all we have to do is you know, make the flap pivot, because we want to control the flap. So yeah, so in order to do that, well, first thing we need to do is we need to make a variable. So this variable is going to control the angle of the flap. So sure, we can. It doesn't really matter what we set it to. Let's just do 25 because so it's to flap angle. Now we've got this variable inside of our assembly model. And that we should be able to reference that variable from our sketches, and that will allow us to, yeah, okay. So click on your. This is kind of the tricky part, figuring out exactly. You know, there are all these numbers here. What do they mean? I'm not really sure, but. Click on your sketches flap under the assembly little section, attachment. Yeah, so we want to click on attachment, I think it is. Yeah, that's about right. So we're rotating it around the y-axis. Yeah. Okay, so this will do translation. Don't really know what this does. And then this will use this window to adjust the rotation. That's what we want. And if you look at the coordinate system, yeah, we're manipulating. We want it to pivot around the y. Okay, so you click this button. If you want the number to be like an expression, so just type in VA, and this window for some reason is really finicky. Sometimes if you don't click on things, they'll like, yeah, it's just a little bit weird. So we type in variables, which is referencing that variables document we made earlier. You can also use spreadsheets and probably some other ways. So variables dot, what did we call it? Flap. Yeah, flap angle. Okay. Let's hit apply, see what that did. Boom. Okay. Yeah, that's what we wanted. Now we can go back into variables, adjust it, say 0. Okay. What do I press? There should be like a recompute. Oh, we're not in assembly. Okay, yeah, so update assembly. Yeah. Okay, that's what we want. So set that to 5. Recompute. Yeah, we'll go down a little bit. And if we want to have sort of be able to manipulate this in a little bit more fluid a manner, we can click on animate assembly right here, and it'll ask us what. So the Assembly4 animation works by pretty much just manipulating variables that you have to program. So we just pull the flap angle, we set begin range, so that might be -5, and then the end range might be 5, or let's try 10, -10. Okay, step size. So pendulum loop will make this run continuously. So if we click run, just start back, and then pendulum, it'll cause it to go back and forth like this. So stop. Yeah, so we don't really want it to go past 10, because that's just doesn't make any sense. Okay, so now it maxes out at 8. And we probably want it to go a little bit higher than -10. So let's say -20. Now let's try that. -45. There we go. Looks a little bit more like a plain flap. Yeah. So if we wanted this if we wanted this to be 3D and not just 2D sketches, it's actually pretty easy from here. We would just go into, back into our design, open up our sketches, we would make wing, pad this, body, okay, pad, so maybe we want this, say 50 millimeters. Back to model. Yeah, and this right here is why you would probably actually want two separate documents, one for the wing and one for the flap, because now they're going to be on top of each other, but that's fine. So that was 50, so let's make this, let's make that the document. So this one is 25. Ooh. Okay. Yep. Okay, so now we just need to save all, back to assembly, and just like that, it has automatically updated. You might not really be able to tell what's going on, but yeah, okay, so just the appearance. Don't know why. So it's all set to be so dark. Okay, that's a little bit better. Just make that. Okay, yeah, sure, whatever. Color. Okay. Whoops. I've just destroyed. Here. Yeah, okay, this looks perfect. Obviously we have overlap here, but it's fine. So if we go back over to Assembly4, this will still run as normal. Obviously it doesn't really like what's going on here, but yeah. And then if you wanted to say move this panel or this the flap, if you wanted it to be, say, centered in the wing, you would just do the same thing that we did to locate it in the first place. So assembly attachment, and we're moving it down the Y. Say translation Y. So 25. you want half of 25, so 25 divided by 2. Cool, that's the wrong way. Negative. There we go. And there we have it.